Hey kids. All right. Today, I thought we'd do a little show and tell, a little check it out, a little how do you do that, Mr. Groom? All right. So I brought out some stuff, put it on the table out here. We're going to be looking at, uh, you know, how to use one of these meters effectively. So, as I mentioned the other day, what else? Here's our meter. Beautiful. Now I wanted to start off doing a few resistance measurements. I'm going to put it up here on the ohms button. Make sure it says ohms right there. Make sure you're plugged in appropriately. Always black in the common. I can't decide which one goes where. I don't know. Black, whatevs. And then we want to do ohms. So we're on the ohms side. Beautiful. Now before you begin taking measurements, it's important to know that your leads are good. So these ones have the alligator clips on them. Chomp, 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 chomp. Now, go ahead and connect them together thusly, and then check and see what you got over here. So I'm running right around 0.1, 0.2 ohms. Now listen, friends, if you have more than about 0.2, maybe 0.3 ohms, get some new leads, because that is going to start throwing off your measurements, okay? Now, got another one over here. Got the other style of leads, the probe style, straight probe style. Again, it's set up correctly here. And touch the two together. Oh, but you're touching them. Isn't that a problem? Not really. This set isn't quite as good. They're at 0.2. It's satisfactory, but it's not as good. Whatever. Okay. Now, thought we'd do a little testing here on a few of these here light bulbs and other resistors to see what's what. Now what I've got here is this nice cute little light bulb, and as you can see inside, maybe, focus you hippie. You see that little coily deal? That's the filament. I'm going to force electricity through it. It's going to get hot. It's going to start to glow. Whoa, that's cute. It is cute. Now down here, you'll notice there's two wires in there. Nice. Now, it's kind of hard to get the big fat alligator clips. You shamed them for being fat, Mr. Groom. They don't really fit in here too good. Okay, I can get one of them on, but I can't really get the other one on. So, you're like, well, use the straight probes, Mr. Groom. Well, that's a good idea, except that it's really hard to touch them both at the same time. Like one here and one there, and oh. So, I will use what we call jumper wires. These wires have tiny little alligator clips on them. We use them a lot in these classes out here because oftentimes we want to get into something like this. Or sometimes in a circuit, we're going to be like, Mr. Graham, I think that part is bad, but I don't know what to do. What earthly thing should I do, Mr. Groom? Well, here's an idea. You could take a jumper wire and you could, wait for it, jump around it. Well, what do you mean? Like, well, just go around that component. So, for instance, if you had a series circuit set up and you had a light bulb that had gone out, and of course the whole circuit's dead at this point, you would be like, well, what's going on? I feel like, and what on earth should I do? Or what's going on here? Well, the thing to remember is, come on, moron, get up here. So the thing to remember is when you're doing these guys is to pay attention to the, is it a sequence, or is it a series, or is it parallel circuit? And if it's a sequence circuit, what's going on? Piece of garbage. Come on. All right, that is not going to work properly. So I'm not going to do it that way. Now, Mr. Groom, you said it would work. No, I said I was going to try it that way. It doesn't always mean it's the best way. Anyway, what I was saying was that sometimes if you want to test if that component is bad, you can actually just jump around it using a jumper wire. Basically take it out of the system and run power around it, okay? Kind of like I have to do sometimes with people that I work with or, whatever, other people in my life. You're like, they're in the way. They are, so just work around them, okay? So I'm just going to touch this probe there, touch this probe here, and I get 0.4. Let me get this where you can see it. Of course, it's always got to be something. So I'm just going to touch there. And touch there. Come on, you got this, Mr. Groom. I have faith in you, Mr. Groom. At least you did it 5 minutes ago. You should be able to do it right now. 0.4 ohms. Bam! All right. Which, as you can see, Mr. Graham already wrote on the back of it like so that he could refer to that. Interesting. Interesting. Now, you've done that with a bunch of this stuff. You know I have. Like on this fella here, this guy's got 2 elements inside. Wait, what? That's right, friends. There's 2 elements in there. Why, they look different. They do look different. Maybe that's why one of them has twice as many ohms of resistance as the other one does. What? That's right. So, there's that. Now, sometimes in a harness, you will find that you have these itty bitty teeny tiny little focus. This one up here in this corner and the one in the bottom corner where the wires go in. Okay? Now, if you look at that, how am I going to get in there with one of these deals? Now, these ones, you can just barely touch them, but do not jam them in. If you jam them in, they make the hole too big, and in the future, when you put this, plug it back into the other component, it's not going to fit well, and you're going to cause a problem. What we call this, when you take this out, we call this face probing. You have to be gentle when you do it. You just barely lay it there. You don't jam it in there. Now, as a general rule, we don't like face probing because people don't tend to be gentle. They tend to be, well, you know, the opposite of gentle, Mr. Groom. Now, this one's actually got 3 wires in it. So there's actually a black one, a green one, and a brown one. If you come down here, you're like, oh, there they go in. If I was a betting man, I'm going to say black is my ground. And so I'm going to gently face probe those guys, and I'm going to get, wait, it's not showing up. I feel like you said it would work. Now listen, I can't get the probe. If you look at it, the probe doesn't fit into that little hole right there. It's not making contact with the metal. What do I do? What do I do? Calm down. You're going to go to your mom's desk drawer, and you're going to, or whoever's, and you're going to get out a paper clip, and you're gently going to lay it in there. It doesn't fit very good. No, that's good. We don't want it to be fit tight, friend. We want it to just slide in there. Oh, that's cute. Wait, would this be a good job now for the well, if you could hang on to them, it would be a good job for the alligator clips now. And why is that? Because, well, their whole point is to, grip onto things so that you don't have to try to balance 18 things at the same time, Mr. Groom. This might be helpful. It might be helpful. Let's see if it does work. See if it makes a liar out of me or not. Gosh. Get that where you can see it, friend. Oh, one-ish ohms on that guy. Beautiful. Now, I'm going to go down to this other one. And we're going to get about 3-ish ohms on that guy. I haven't written this one down yet, so 1-ish ohms and 3-ish ohms. I'm going to write that on this tag so that later when I go to use it, I can know that, hey, this one, oh, what does that mean? Can you tell me what that means? I didn't tell you, but what does it mean, friends? It means that there were 2 filaments in that bulb. 2 filaments. One, of course, is going to be brighter than the other one. 1 and 3 ohms. Beautiful. And I just wrote them on the back of this tape here so that if I need to do it again in the future, I can go back to it. Nice. Now, you're like, what are you going to do to all those, Mr. Groom? You've done this to all those light bulbs. Well, I'm going to continue, and in a couple of minutes, I'm going to bring you back in, and we are going to do a few examples here on camera. Here's an example. Ooh, it's a headlight, Mr. Groom. That's right. This one tested about half. This one tested about 1.7. Ooh, doggy. Ooh, doggy. Okay, so Mr. Groom is going to continue for a few minutes here, dinking around, and then I'll bring you back on camera with me. All right, so we're resumed. Okay, so over here we have a battery, of course. You can see I'm going to connect these jumper cables to it, and I'm going to use my jumper wires to the jumper cables, okay, just because it's easier to hook on. So I'm going to build a little circuit over here. So the first circuit I'm going to do is I'm going to build just a 1-light circuit with one of these headlight bulbs, okay? So I'm just going to take Jumper wire like so. I'm going to use a little bigger jumper wire than those little yellow ones. The little yellow ones are kind of puny. We could be actually pulling a lot of current. Well, we will be pulling quite a bit of current through this guy. Those yellow wires could get kind of toasty. If you were here, I would probably do that just for fun, just so that you can see that, whoa, hey, when current happens, it gets hot. Okay, now that should not be rocket surgery. I mean, it should be fairly straightforward, obvious that that's true. Because you know that the more people I shove through the hallway to go from B building to A building or whatever, okay, of course, the more I send through there, the hotter it's going to get. Okay? And if you're not a people person, you understand that, whoa, it's going to get so hot in there. Whoa, that's bright. Judas Priest, Mr. Groom. That's right. Now, friends, what would happen if I did the next thing I'm going to show you? Let's think about this for a moment. Okay? I am going to take this light bulb here, which is the exact same resistance. It's a different model, but it's the same exact resistance. First of all, you're like, the same resistance? Why, I bet it's going to be the same brightness as the other one. That's true. Watch carefully. It's coming from here, through this one, and back to the battery. Okay? Now, what is that kind of circuit called? Wait, like it has to go through all of them, Mr. Groom? That's correct. Well, wait, that means it's going to be a series. That's right, it is going to be a series. Well done, sir, ma'am. Good job. Exactly. That's all you got to think about. It's a series because it has to go through all of them. Let me pull this back just a skosh. All right, there we go. Okay, now I'm going to slide that back over it. It's a bad time if those guys were to touch one another, metal to metal like that. That would be a bad time. Okay, now watch them, keep an eye on them. Well, Mr. Groom, they were dimmer. Well, how about that? Now, why is that? My eyes got a blind spot because I was looking right at the one when it lit up. Awesome. Great. Good job, Jay. Now, listen. The reason for that is because they're in series. What happens when you are in series? When you're in series, is there more or less resistance? There's more resistance. And if there's more resistance, there is less current. Less current means less power. You recall P equals IV. Okay? So two things here. First of all, that's a 12-volt battery. If these are equal bulbs, which they are, that means they're going to have a 6-volt drop on both of them instead of a 12-volt drop. Okay? If you are Ed the electron and you are standing right here, you cannot see back to the battery because this guy's in the road. If you were Ed the electron and you're standing here looking back, that guy's in the road. You're like, what the heck? What the heck? Again, if they're the same, that's equal voltage drop. 12 volts divided by 2 is 6 volts. So if P equals I times V, if you went from a 12-volt drop over one of them to a 6-volt drop, right there you've lost some power. And there's more resistance, so there will also be less current. So I will also be smaller. It went from being, whoa, that was bright, to, really? It's kind of sad. It is kind of sad. Now, also note, what would happen if one of those light bulbs burn out this way? They would both go out. Mr. Groom, I know what you're thinking. Mr. Groom, can you build us a parallel circuit? You know, by George, I can. By George, I can. Now, what I'm going to do is I'm going to take the plug that's on the left. It doesn't matter which one. I'm going to do that for both of them. And I'm going to run it over here to the positive, or to the negative side over there, okay? And then I'm going to get another jumper wire here. And I'm going to go in, and I'm going to connect both of their positive sides to the positive side of the battery. In other words, both positives are hooked together, both negatives are hooked together, and so what we have then is a parallel connection. I'm just going to use a third one here, just to make my life a little easier, I don't have to try to like hook two of them to the battery at the same time. So I'm going to hook just this to here, like so. Again, these are just connected together. That's all that's doing. Okay? See if I can do this. Now, whoa! Holy mackerel, that's bright. Now, why is it brighter? Okay, well, again, in parallel, what happens to our total resistance? It goes down. And then if it goes down, what happens to your current? It goes up. That's right. Not only that, you also have, both of them can see straight back to the battery. Therefore, they both have 12 volts of voltage drop. So P equals IV, my I has gone up, and my voltage has gone up. Therefore, my power has gone up. Hence, whoa, bright light bulbs over there. That's exciting, okay? That's what we've been talking about in the classroom, okay? Now, Mr. Groom, is it possible, would you mind, could you possibly show us what kind of current, how much current these guys are drawing? I can do that. Yes, I can. I think so. Sure. Let's find out, shall we? So I'm going to move you just a skosh closer to it here, height. And what I'm going to do is take this one, I think. And recall that if you are using an ammeter, okay, remember how to set this up. Okay? So an ammeter, we're going to be measuring the amps. So, focus, you hippie. All right, so we need to be over here on the amp setting. So, boop. Now, typically, but not always, it's going to beep at me because it's going to tell me this is in the wrong slot. It needs to be in the amp slot over here. There we go. Also note that it needs to say, where did I put my glasses? Judas Priest. I wonder why everything was so out of focus. There we go. Notice it says AC. Listen, friends, I want the yellow, the straight line. That's DC. So hit the yellow button. Now we're in DC, babe. Nice. So remember, when we set up the ammeter, okay, what we're going to want to do, you see, is we're going to want to run all of the power through our meter. So I'm going to hook this feller like here, like so. Oh, maybe. Oh, Judas Priest, Jay. And then I'm going to go ahead and connect this guy. And if we don't screw it up, this will work nicely. Now, I say if we don't screw it up, I kid. But if we happen to pull more than 10 amps, this fuse right here will blow up. It's not the end of the world. It's there to die to protect you. Well, the meter. Whoa. We're pulling almost 8 amps of current. Hey, that's pretty sweet, dude. Remember, in order to do this, all of the current must pass through the meter. It has to. Okay? So, I think in a second I'm going to pause. If I was smart, I would have done this a little bit differently, but it's okay. I can do it. What I'm going to do is I'm going to draw this circuit up for you, maybe on paper. Now, you're like, actually, I'm not going to draw it up. We'll talk more about it. We've done enough drawing. I'm not going to do it. Mr. Groom, what would happen if this bulb burnt out? Well, what do you mean burn out, Mr. Groom? I mean, what if it just died? What? You mean like burn out? Yeah, that's what I'm saying. Would this bulb get brighter or dimmer? Or would it go out? Well, it's not going to go out, for crying out loud. It's a parallel circuit. That's the whole point of a parallel circuit. Now, what I'm going to do is I'm going to get my gloves on because that bulb is now a little toasty warm because it's been on for a second or two. And what I'm going to do is I'm going to, over there, while it's running, I'm going to unplug that bulb over there. Okay? Two things I want you to do. Pay attention to this bulb. Is it going to get brighter or dimmer? I'm just going to unplug it. It's the same as if it had burnt out. It's the same thing. Okay? I want you to watch this bulb. Does it get brighter or dimmer? And I also want you to pay attention to that current right there. Okay? Keep an eye on it. Okay? Let's try this. I'm going to get my glove on. All right. Yeah. All right. Wait, what happened here? Okay. Oh, yeah, here we go. Hook them up. There you go. Now I unplug this one. Wait, did it change color much? Okay, I don't know. Did it? What happened here? We went from 7 amps of current down to 3.5 amps of current. But I don't think that changed colors too much. Can you show us again on live camera, Mr. Groom? I think so. That guy hasn't changed colors too much, has it? No. Now, why is that? I saw the current change, Mr. Groom. I saw it get less current. You did. But you know what else happened, friends? The reason that happened is because when I unplugged that bulb over there, instead of having two parallels, let's use nice, easy measurements. Let's say they were both 10 ohms. If they were both 10 ohms, the total resistance would be 5, correct? But when I got rid of one of them, it went from having 5 ohms of resistance to what? To having 10 ohms of resistance. That's twice as much resistance. That's why that cut the current in half. And you're like, whoa, whoa. But Mr. Groom, it didn't get brighter or dimmer. It did not. Because remember, power, which is the dimness or brightness, power is equal to current times voltage. And you're like, but there was more current before. That's correct. There was more current before because there was more resistance before. Okay, or there's less resistance before, so there's more current. Okay, but half of the current went through this bulb before. Yes, there was 7, 8 amps of current, whatever it was before, 7 or 8 amps of current before. Okay, but only half of it went through this bulb. Okay, so only 3 point whatever amps of current went through this bulb before. The other 3.5 or whatever went through that guy. Okay, but when I unplugged that guy, now there's only a total of 3.5 or whatever amps of current, and it's all going through this guy. This guy is ignorant, happily ignorant that anything's wrong with that bulb. Doesn't even know. He's just doing my thing, getting hot, burning, putting out some light. Don't even care what that fella over there is doing. Don't care. But he's dead, don't you? No, I don't care. I'm doing my thing over here. Okay? Now again, that is a big deal. If that were not true, you go down the road, you'd see this guy with that one headlight because the other one burned out, just 8,000. Oh, I can't see with one light. That's weird. That is weird. The bulbs on your car, if you see a padiddle going down the road, one headlighted car, why, shoot, it's the same brightness as it would have been if the other one had been on, except there's only one bulb on. That is a big deal. Also, if that headlight burns out, this one I'd like it to stay on, please. Thank you very much. Therefore, it's important we use parallel circuits in these situations. Okay, that's why we do it. I'm going to pause you for just a second whilst I set up another experiment here. Okay? Okay, so I've set up this fan here now. Just a single fan. It's just in series. Obviously, you can't be anything other than series with yourself, for crying out loud. I'm just going to touch it here. Get rid of some of the junk out of the way. Hang on. Okay? Just going to touch it here. See what happens. Whee! It spins, Mr. Groom. It does. That's a shocker. Mr. Groom. Mr. Groom. Mr. Groom. Mr. Groom. What would happen, Mr. Groom, if you were to measure while it's running, okay? What would happen if you were to measure the voltage drop across that fan? What do you mean, Mr. Groom? Good question. Good question. What if I were to take right here and go and measure the voltage drop from thither to yon? Okay. Now, what I'm going to do is I'm going to actually just use a jumper wire to get over there. So I don't have to hold everything together at the same time. I mean, good night, nurse. It's a lot to hang on to. Hold it there and there. Whatevs. And I'm just going to take this other side right over to the battery over there in a second when I get ready to do it here. Okay, now, you're like, Mr. Groom, I feel like it's going to be 12 volts. And you feel correctly. You're absolutely right. Now, why is that? Okay, well, it's because, Mr. Groom, well, okay, I say 12 volts. It's going to be whatever the battery voltage reads is what it's going to be. Thank you very much. And that's because if you are Ed the electron and you are standing right here, why, that's the same as standing right here. And you can go all the way back to battery. And if you're Ed the electron standing here, why, you can get all the way back to the battery. So, of course, the voltage drop will be whatever battery voltage is. Let's check it out. You can see this battery is kind of weak. It's only running about 10 volts. This is not a good battery to run your car on. It is whipped. It will run little sciencey projects like this. That's why I've kept it around a little bit. I've got a bunch of them that I just keep around. Also, when you buy a new battery, you got to get rid of an old one. So, whatever. Not a good battery to try to start your car with. It will not work. In fact, let me just show you over here. Suppose I were to take this battery, this guy, and I'm just going to test the voltage right at the battery. And so here it is. I'll set it up for you. Do you hear that? She's complaining, and she says lead, because this one's here is in the wrong hole. Move it over here. Beautiful. Here we go. So I'll put this baby on the negative side. Put this one on the positive side. And lo and behold, what do we got? That basically 10 volts. Oh, well, it would if it'd stay on. 10 volts. Now you're like, it's a little bit more. Well, sure. But you'll notice that the connections here are not great, and they're not great right there. We've introduced a little bit of resistance with those alligator clips. So it's not perfect, but it's pretty close, okay, to what the battery is actually saying over here. Okay? Now, Mr. Groom. What if you put a light bulb, Mr. Groom, in series, okay, with this fan? What if you took one of these light bulbs we used earlier, see if one of these is cooled down enough to touch now. Yeah, I guess this one's okay. And let's run the power through the fan first, okay? We'll come out of the fan. We'll go, now this is kind of a cluster of a mess here, so you'll just pardon me how I'm putting this together. I'm going to come into this bulb here. Oh, Judas Priest, be careful, you dummy. One moment, please. We have to be careful. When you be careful with these things, if they hit the counter and it's metal and this other one's hitting the metal, it'll short out through the back of the battery, which will be not optimal. Less than optimal, friends. I think I'll set that in there for right now. Okay. I'm going to go into the bulb. Why? Oh, yeah, you're looking at me. That's a good job, Mr. Groom. I'm going to click here on this bulb. Like so. Oh, I'll do it the other way, stupid. There you go. Cover it back up. Good. Grab another one. Same deal. Got it on there, good. And now I'm going to go back to battery here, okay? Now, I'm going to do that in a second. But I want you to focus on what is the voltage drop here, okay? And that is going to be from, this is still across the fan. Now, remember, the battery voltage right now is right at 10 volts. When it was just the fan, we dropped all the voltage across that guy. But now we've introduced this feller here. This will no longer say 10 volts. This is going to say a different number. We're going to do it both ways. We're going to do it here, and we're going to test it across this guy as well in a second. Okay? In fact, I'm going to hit pause and get another meter set up so we can watch them both at the same time. I'm running out of jumper wires. In theory, when I turn this on momentarily, we should see two different voltages, and they should add up to about 10. So that one says 9 point something, and this one's not hooked up correctly. So something's a little screwy here. We're not making good contact somewhere. Oh, wait, Mr. Groom, you're an idiot. No, you did it right. You're still stupid, so good job, dummy. Okay, I'm going to come in here and try this again. Oh, wait. No, that's right. Wait, what's going on? I feel like there's an issue. What is up, Mr. Green? Judas, effing priest. All right, so if I hold it correctly, it's about 1.7. 1.7 plus, the other one said 8.3. 1.7 plus 8.3 is, wait for it, drum roll please, 10, yay! What did you notice, okay? Who has more resistance? That guy does. That's why it takes more voltage to push current through that guy than it does to push it through that guy. Mr. Groom, there's not a lot of current. Well, how do you know there's not a lot of current, Mr. Groom? Well, two reasons I know there's not a lot of current. These guys are in series. That guy must have a lot of resistance because that one has almost none, 0.4 ohms. That one must have a ton of resistance, which is then knocking down the current. Also, that guy now only has 1.7 volts of voltage drop across it. Power, that is our glowing ability, power is current, which again is very small because that sucker has a lot of resistance. And two, there's very little voltage, 1.7 volts. This guy is not going to have much power. That's why he barely lit up at all. There's almost no power anymore. Okay? So these are the kind of things I want you to have in your head as you're doing these guys, to be able to think about it like that. Now, here is another thing that I'm going to demonstrate. I'm going to pause you while I set it up. So for this little experiment, you can see over there that I have a piece of metal clamped in over there. Now watch what's going to happen. This is how it's set up in your car. It's your battery. The negative post, the black one there, is going to go to the body of your car. That's the metal. So when I set this next experiment up, whether I use 2 bulbs or 1 bulb, really neither here nor there, I guess, I'm going to take one of my wires and I'm going to go to positive. Beautiful. Well, actually, I'm going to set that for last. Take the other one and I'm going to go to ground. So we've been drawing that to ground situation. Well, that's what we're doing right here. I went to ground. Whoa, it lit up. How exciting. But it's not really back to the battery. Well, it looks like it is, but this right here is the body of your car. It functions as another wire in the system. That's how we set things up in automotive wiring, almost exclusively, okay? So we do the same thing on this guy. I'm going to also ground, quote unquote, ground him. Oh, there he is, grounded, whatever. I'm going to take another one. So I'll have 2 of them going back to battery this time. Let's see where we at here. This will be a parallel circuit, as one can clearly see. Okay? I'm just going to hold them in my hands together when I touch back to battery here. Whoa. Hey. Yay, look at that. What? Oh. Watch you melt the wire, Mr. Grimm. Now again, here we go. Whee! One of them burned out. The other one didn't change. One of them burned out. The other one didn't change. What? What? Remember, that is a big deal that I want you to be able to really get your head wrapped around. Okay? In a parallel circuit. Okay? Yes, there is less resistance. Yes, there is going to be more current. However, part of the current goes through this guy, half of it in the case of 2, half goes through this fella. This guy is happily ignorant of this guy over here and vice versa. If this one kicks the bucket, I'm dead. Oh no. He probably didn't say that because he's dead. This guy is going to march on as if nothing ever happened because he only ever got half of the current anyways. So when this guy dies, there's only half as much current as there was before, but this guy gets all of it. And it's the same. That's why you see no change in brightness of the bulbs. Okay? Now, this was a demonstration purposes sort of day. Okay? Now, you're like, cool, all right. Do I have an assignment today? No. But on Monday, and you should take notes on this, of course. On Monday, what I want you to be able to see is to look at this and go, Mr. Grimm, when I ask you questions, I want you to go, oh yeah, I know the answer to that. Okay? Have a great weekend. Bye-bye.